So, welcome to the live interactive session, week one of the NPTEL course Engineering Mechanics. So, uh, this is like live interaction where I will be going through some demo problems and I will show how to solve these problems. So, main motive is that like usually the NPTEL courses you will be watching the online videos which is already uploaded in the website and you will learn yourself, but here like in these sessions me and I think one more TA is there who will be conducting this online sessions where we'll solve similar set of problems which you may encounter in assignment or in some kind of situations. So, we hope like we expect you to come every week, attend these sessions, but before coming that you have to also watch the at least the videos which is already uploaded in the website prior to that week. So today I hope you have already watched the week 1, week 2 videos. So you will have a basic understanding of the course. Then you can simply follow what I am like teaching here. I am not teaching, basically I will be solving some demo problems. I want it to be an interactive kind of a session. So each problem I will pause a minute so that you can try yourself. Then some problems will be like multiple option or MCQ kind of thing. So where the options will be displayed, you can either respond to like through audio or through chat box which option you think is a correct answer. Then I will be finally show exactly how to solve that problems. In addition to that, this session will be like almost 1.5 hour or 2 hour kind of session. So I will have some set of problems which I may able to finish before like probably 1 hour in 1 hour. So the remaining time, if you have some queries, you can ask. So I will be available to clarify that. So with that, I think I can start. So I will move to the first problem. So I hope you all can see the question and the respective figure here. So find the magnitude of the net moment in Newton meter acting on the disk about its center. Round your answer to first decimal place. So this is fairly straightforward. Basically, you have to evaluate the net moment about the point, about the center O. So there are various forces acting on this disk. So I'll give a minute for you to try it out, and if you found the answer, please respond either in chat box or through your mic. Unmute yourself. So please go ahead. So I'll wait for a minute. Then I will explain how to solve it. So for those of who joined later, so I'll be solving some demo problems. So the first of the kind is displayed here. So basically you have to evaluate the net moment about the origin or the center of the disk O. So I'll pause for a while for you to try it out. If you found the answer, please like you can type it in chat box or you can unmute yourself and tell the answer. So if you have any queries, please stop me and ask me. So anybody has the answer? Okay, so we have an answer in the chat box. So I hope by this time everyone could have finished this. Still I'll wait for a while. And okay, I think now I can start explaining. So I expect it to be an interactive kind of session. So uh, can anyone tell like which of the forces are going to contribute to the moment and which of them are not? Okay, let me label the forces. Let's say this is F1, 5 Newton, and F2, which is 2 Newton, and F3 is 10 Newton. We have to evaluate the moment about the center O. Okay, so moment about O. So I think all of you know, basically if you have a lot of forces acting on a system, we have to just take the sum of all the moments about the same point of the so this is the resultant moment, which is basically the individual moment about the same point caused by the individual forces. So here if you see, it's basically moment of individual forces can be evaluated with a cross product between the moment arm, which is the distance, the perpendicular distance from the point where we want to evaluate the moment. So here it is the origin O. So we have to find the perpendicular distance from the point O to the force, which of the force we want to take the moment, and take the product between them. This we have to add over all the forces which is acting on the body. So here if you see, we have F1, F2 and F3. So we have to basically evaluate the moment caused by the force F1, and then F2 and then F3, take the sum of all. So we have to bear in mind that the direction in which the moment is acting, so it can be either clockwise or anti-clockwise. So depending on that, we have to do a sign convention. So we can choose either counterclockwise as positive and clockwise as negative, or the other way. Whatever convention we choose, just stick to that convention. So one more thing that we may need to use here is that since the forces F1 and F2, which are not exactly acting, I mean, let's say this is x direction and this is y direction, so they are not exactly acting in either of the x or y direction, which is just they are inclined forces acting in some angle. So we could just resolve them into component forces. It will be easier for it to do. Otherwise, you could still evaluate the moment arm of the force from the center O. So either of the way you can try. So I prefer the easiest way, where you can split the force F1 into its components. So F1 will have component F1 cos 45 along this direction, and F1 sin 45 in the vertical direction. Similarly, F2 will have F2 cos 30 in the vertical direction downward, and F2 sine 30 in the horizontal direction, basically in the negative x direction. So these component forces, so basically we need to now for F1 and F2 we just need to evaluate the moment of these component forces about the origin. For F3, this is the answer of the first question that I have asked: which of the forces are going to contribute to the moment and which one of them are not going to. So if you see here, F3 is basically passing through the centroid, right? So the moment arm of the force F3 is basically 0. So F3 will not have any contribution to the moment. Similarly, F1 sine 45, which will not have any contribution because that is also passing through the origin. Similarly, F2 sine 30, which is also passing through the center O. So these three forces, basically two components, F1 sine 45, F2 sine 30, they don't have any moment about O. They are not going to contribute to the moment. Just that F1 cos 45 and F2 cos 30, only these two forces are going to contribute. So the net moment will be F1 cos 45. So the moment arm of F1 cos 45 is just, so you can see it is just r, the radius, which is 2 meter. Similarly for F2 cos 30, also the moment arm is r only, which is the shortest distance or the perpendicular distance to those component forces. So basically F1 cos 45 times 2, but now it is F1 cos 45 is causing a moment which is clockwise, so I will choose that to be positive sign. Let's say the clockwise is positive and the counterclockwise is negative. Just the convention, doesn't matter, you can choose the other convention also. Finally we just need to specify whether it is clockwise moment or anti-clockwise moment. So F1 cos 45 into 2, the moment arm, and F2 cos 30 is the other component force which is causing the moment, which is also 2 meter apart from the origin, but now that is causing a counterclockwise moment. So I will take it as negative F2 cos 30 times 2. Remember F1 has a value of 5 Newton, so 5 into cos 45 is 1 by root 2 times 2 minus F2, which is 2 Newton, so 2 times cos 30, which is root 3 by 2 times 2. So you can simplify, you will get 5 root 2 minus 2 root 3, which let me evaluate it. So it's approximately 3.61 Newton meter. So I think in the chat box somebody had replied the same answer, so that's the answer. So I hope this is clear. Anyone has any doubt? Basically it's an easy question. I took a lot of time to explain this. So anybody still has any doubt? Okay, good. So then I will move to the next problem. So I hope the question is visible to everyone. So we have a rigid beam which is weighing 10 kilogram, which is pinned to a wall on one end, the left end, and is supported by a cable attached to its other end, as shown in the figure. A block of mass m is suspended from the beam. If the supporting cable can withstand a maximum tension of 300 Newton, which of the following are permissible values of m? So there are 5 options given: 14 kilogram, 7 kilogram, 25 kilogram, 30 kilogram, 40 kilogram for the permissible values of m. We expected to have more than one solutions to be correct. This is a MSQ type question. So like earlier, I'll give some time for you to try it out. If anyone found some answer, you can put it in the chat box or unmute yourself and say it loud, whatever. So it's basically um, a moment balance problem again, basically equilibrium problem. So I hope you all know how to solve equilibrium problem. So it's 2D system. So basically you have to consider sigma fx equal to 0, sigma fy equal to 0, and net moment equal to 0 for equilibrium. So here we need to find the permissible values of m. For that, the maximum tension which can be allowed in the string which is given, which is 300 Newton. That's the only thing that we need to remember. And one more tricky thing is that it's a minute thing that the total length of the beam is 1 meter, but it is hinged at the end by offsetted by 0.05 meter. So that thing you have to bear in mind. So with that, I hope you can try it out for a while, and probably in 2-3 minutes I will start explaining how to do it. So try to solve before that. Okay. So I saw somebody has raised a hand. Okay, go ahead. Do you have any question? Okay, I think that's a mistake. So anybody has any luck? Has anyone found the answer? So let me help you. So I am going to draw the free body diagram of the beam. Okay. So I hope everyone know how to draw this. See, if anyone don't know, please stop me. I will explain in detail. Still, I will explain something, but if anyone uh, need to have a detailed explanation, I can explain that. So this is a beam. So there a mass is hanging at this end, M, which is having a weight of mg, which is a force acting, which is 0.75 meter from the end where it is hinged. So let's say this is the location, it is hinged. Now okay, so in the chat box we have an answer 25 kilogram, so I will mark here. Remember that this is an MSQ type question, so we can have more than one answer. So what are the permissible values of M? That's a question. So if anyone found any other answer, you can still reply. Okay, come back to the free body diagram. See, if anyone found any mistake, please inform me. Otherwise, I will be solving wrong things. Okay. So yeah. So at this end, we have a tension. Its maximum value is 300 Newton that we will use later, but a tension is acting at the end. Now, so the 0.75 meter is basically it's marked that it is actually measuring from the hinge, not from the end point. So that's fine. And now it's actually a hinged joint, so you will have two support reactions there. One will be a vertical and another will be a horizontal. So let mark the horizontal one this way. So this is reaction horizontal and this is a reaction vertical. Let me mark the hinge as O, so that the moment, or we will take the moment about O to solve the problem. One thing that we are missing is that weight of the beam. So it's given that 10 kilogram is the weight of the beam. So it should act through the center of mass, right? The center of mass is basically somewhere in the center of the beam, and through where 10 kilogram is the mass, so 10 times g is the weight which is acting. Now from the O, the center, where exactly it will be located, that's a trickier thing. That actually it's 1 meter long beam, so its exact center is actually at half the meter, so where 10 kilogram is acting. But remember, from the we want the distance from center O, I mean it's a hinge point O, which is 0.05 meter offset from the origin. Sorry, not the origin, from the end. So that it's basically 0.5 meter minus 0.05 meter. That is the distance of the 10g, the weight of the beam from the center O. So we are measuring every distance from the hinge point O because we want to take the moment about the hinge point. Now the tension is also acting at the other end, which is basically 1 meter from the end of the beam, but we want to find the exact distance from the hinge point, which is O. So that is in a similar way, this distance will be again offsetted by 0.05 meter, so it will be 1 minus 0.05 meter. Now the tension, which is basically, the string is basically at a 60-degree angle, so you can have, like the previous problem, you can resolve this into two components. It's a horizontal component and vertical component. So you can have t cos 60 and t sin 60, where this angle is 60 degree. Now you can so basically you can go ahead with um, the equilibrium equations: sigma fx equal to 0, sigma fy equal to 0, sigma m equal to 0. But here basically you want to find the unknown m for a maximum value of t. You really don't need to evaluate the horizontal vertical support reactions RH and RV. If you just take the moment, I mean, there's nothing wrong with, okay, we have a comment saying Siddharth is saying 14, 7 and 25 are the possible answers, so I will just mark them. So we'll come to that. Okay, so what I was saying is, so we can still solve sigma fx equal to 0, sigma fy equal to 0 and sigma m equal to 0. So we will evaluate horizontal vertical moment, and then finally we will, when we take the moment equation sigma m equal to 0, we will able to evaluate the unknown mass m. Now if you take the moment about the hinge point O, the horizontal and vertical support reactions are passing through the hinge point O, so they are actually not causing any moment. So in the contribution of the moment about O, so this is the equilibrium equation. So for equilibrium moment of the system about any of the point equal to 0, if you choose the point to be the hinge point, then there is a good thing about that: the horizontal and vertical support reactions are passing through the hinge point, so they will not cause moment about that point. So just that the other forces are enough to evaluate the moment. So that's what we are going to do now. So like I said, horizontal force and vertical force support reactions, they are not causing any moment. Let's say the clockwise moment I am taking positive and counterclockwise as negative, like earlier. So 10g is the next force, which is the weight, which is acting 0.5 minus 0.05 meter. So the moment arm is 0.5 minus 0.05 meter, which is acting, sorry, the momentum of the force 10g, so which is causing a clockwise moment. So that I am taking as positive. And now again another force mg is acting, which is at a distance 0.75 meter, so which is also causing a clockwise moment. So that also I am taking as mg times its momentum is actually 0.75 meter. Now the next force is tension, which has two components, t cos 60 and t sin 60. You can see t cos 60 is passing through the hinge. If you extend the t cos 60, so that is not going to cause any moment because its momentum is 0. T sin 60 is 1 minus 0.05 meter apart, so that will cause a moment, and that moment will be an anti-clockwise moment. I hope these directions are clear to everyone, the moment directions. So because it's anti-clockwise, I am taking negative sign, so it is basically t sin 60 times 1 minus 0.05. So this is a net moment, and for equilibrium this should be 0. Okay, now the unknown is m. We can solve for m. Just bear in mind that the maximum possible tension allowed is 300 Newton. So if you say that T max is 300 Newton, we can solve for M, the critical value of M. So if you put the maximum tension, you will get M critical, which is 300 sine 60 1 minus 0.05 minus 0.5 minus 0.05 into 10 G. G is 9.8, the whole divided by 9.8 times 0.75. I'm just rearranging this equation here, okay, so that you can get the critical value of M. And I think it's approximately, can anyone help me with that? What is its exact value? Okay, I think it's 27. Yeah, 27.57. So so this is a critical value beyond which the tension in the string will exceed 300 Newton, it will break. So the mass should be lesser than this. If the mass is lesser than this, the system will sustain like this. So the possible values according to the option, 14, 7, 25, everything is possible. See, 25 kilogram is of course possible. 7 kilogram is lesser than that also possible. 14 kilogram is also lesser than the critical value. So basically 14, 7, 25, all these are possible. I hope that is clear. Immediately 25 is clear, but 7 and 14 also possible because it's lesser mass, right? The string will not break if you load a lesser mass. So system will still be like possible, permissible. 32 and 40 are not possible because they are beyond 27. So I hope that is clear. Any doubt in this section? Okay, good. So I hope that is also clear. So we'll move to the next problem. So consider two forces F1 and F2 acting in the xy plane at points 2,2 meter and 1,2 meter respectively. The forces are given as F1 equal to 2I plus 5j Newton and F2 equal to 4I plus 3j Newton. Which of the following statements are true? So there can be more than one statement being correct. So you have to go through every statement and check whether it is correct or not. So this is an MSQ type question. So anyway, we'll go through each of the problems, each of the option and check whether it is correct or not. So the magnitude of, so the first option says that the magnitude of the resultant force is 10 Newton. Is this correct or not? So let me evaluate it. So the resultant, if you have two vectors, okay, Sitar says it is correct. So let us see. So the resultant force will be just the vector sum. So 2I plus 5j plus 4I plus 3j. So the resultant will be just 6I plus 8j. So I hope all of you know the vector addition. Now the resultant magnitude is 6 square plus 8 square. So it will be 10 Newton. So it is correct. So first one is correct. Now the second option, the magnitude of the net moment acting on the plane about the origin is 2 Newton meter. So about the origin, what is the net moment by these two forces? So it is given it is 2 Newton meter. We have to check whether it is correct or not. So the net moment about the origin is basically R cross F, sum of R cross F, where r is the moment arm, so we have to measure the distance from the position vector from the origin to that particular force, then take the cross product between them and add over all the forces. So here we have two forces. So RO1 basically the position vector of the to the first force times that force itself plus the position vector to the second force times the second force. So the first force is acting at the point 2, 2. So origin is 0, 0. So if you I hope all of you know how to evaluate the position vector. So if a point is at 2, 2 from the origin, this is the position vector. The position vector RO1 will be just 2 minus 0i, which is 2i, plus 2 minus 0j, which is 2j. So here, so 2i plus 2j is the position vector of to the first force, and the first force is given as 2i plus 5j. Similarly, the position vector to the second force, which is at a point 1, 2. So 1i plus 2j will be the position vector cross with the second force, which is 4i plus 3j. Is that clear? Anyone has any question in this part? So I hope that is clear. So now just taking the cross product. Just remember the rules. Is it not clear, or is this option is not correct? So somebody has replied that no. So anyway, this option is not correct. We'll come to that. But I hope this section is clear. Okay, good. So yeah, just remember I cross I is 0, I cross j is equal to k, j cross I is equal to minus k, j cross j is equal to 0. So if you use that here, we will have 2 cross 2, so 2i cross 2i is 0, 2i cross 5j is 10k, then 2j cross 2i is minus 4k, 2j cross 5j is 0, then 1i cross 4i is 0, 1i cross 3j is 3k, 2j cross 4i is minus 8k, then 2j cross 3i is 0. So basically we will get 13 minus 12 is 1k Newton meter. So we found the moment is basically 1 Newton meter, and what is given in the option is 2 Newton meter. So that's clearly wrong. So second option is not correct. Now the third option says that the moment exerted by F2 about the origin is 6 Newton meter. So so that I think, yeah, just we need to evaluate this quantity, the moment of the, I hope that is visible. So I was just highlighted this part. This is the moment of the force F2 about the origin, which is just this part. If you remember the previous evaluation, this is 3 minus 8k, which is just 5k in the negative sense, minus 5k, and what is given is that it's 6 Newton meter. So that is also not correct. Is that clear? Or okay, so next option says that the point 0.5 comma 0.5 yeah, I think it is just the magnitude. So even if you say the direction, anyway not going to match. I think it's only the magnitude is asked here, 6 Newton meter. Even if you consider the direction also it is going to be negative 5. The actual moment is negative 5, but whatever is given is 6 Newton, so they're not at all matching, so the option is correct, sorry, wrong. So the next option says the point 0.5 comma 0.5 lies on the line of action of the resultant force. That is, the moment of the resultant force acting on the point 0.5 comma 0.5 about the origin is equivalent to the net moment. So basically the net moment is 1 kilonewton meter. So the point so the resultant force, which is 6i comma 8j here. So the question says that, the option says that this resultant force 6i 8j, which is actually the line of action of this resultant force is passing through the point 0.5 comma 0.5, so that the moment by this resultant force Fr if we consider about the origin, so basically the resultant force is 6i 8j, which is passing through the point 0.5. So the moment caused by this force should be equal to the actual moment mo. Then only we can say they are basically like this force is passing through the point 0.5 comma 0.5. Otherwise, so I think am I making sense? Basically we have so it's given that the point 0.5 comma 0.5 lies on the line of action of the resultant force. Indirectly that means that the moment of the resultant force acting on the point 0.5 about the origin is equivalent to the net moment, which is mo. So if they are same, then we can say clearly that Fr is passing through this particular point, otherwise it is not. So we'll just evaluate and see whether it is same, the moment is same or not. So the net moment is 1 k Newton meter. K is not kilo, it's just the k cap, the vector direction. Positive is the direction it is indicating. So the consider the point 0.5 and 0.5. The position vector to that particular point is 0.5i plus 0.5j. Now the resultant force, if it is passing through this point, then the moment of the system about the origin will be 0.5i plus 0.5j cross the resultant, which is 6i plus 8j. If you just evaluate, it is just 8 into 0.5, which is 4k, minus 6 into 0.5, which is 3k, so which is 1k Newton meter. So which is same as the actual moment of the system, which is also 1k Newton meter. So because they are same, we can clearly say that the resultant force is passing through this particular point, so that option is correct. Is this clear? Any doubt in this point? So basically we are claiming that the resultant force is passing through this particular point, which is half comma half. If the claim will be correct if the resultant moment caused by this force, resultant force that we evaluate, that should exactly match with the actual moment, which is we already evaluated, which is 1k Newton meter. If they are not matching, then the claim is wrong, that the resultant force is not passing through this particular point. Okay, so the last point says that another point, which is 2, 2.5, also lies on the line of action of the resultant force. Same claim, now a different point, 2, 2.5. So we have to again repeat the process. So 2I plus 2.5j is a position vector. Again we repeat the same process. We have to cross with the resultant force. So 2I plus 2.5j cross 6I plus 8j will have 16k minus 15k, again 1k Newton meter. So which is also matching with the moment of the system, which is 1k Newton meter. So the claim is correct. Again this point, the resultant force also passing through this particular point 2, 2.5. So I hope this section is clear. Any question? Okay, so if not, we'll move to the next session. Next question. So if the radius of moon is fourth of the radius of earth, and if earth is 80 times heavier than the moon, the acceleration due to gravity on the moon is, so we have 5 options given. So just you have to use the equation for the acceleration due to gravity on the surface of a bigger body, just the gravitational field on the surface from the Newton's law of gravitation. So I'll wait for a minute, so you can try. If somebody found the answer, please put in the chat box, then I will explain how we can solve this. So I hope all of you know the equation for gravitational field. So G is equal to Gm by R square. So we have a planet. Let me redraw it. So on the surface of the planet, the gravitational field, let it be G, and the radius of the planet is R, then and mass of the planet is m. Then Gm by R square will give the intensity of gravitational. Okay, so we have an answer in the chat box. It's 5 times smaller. Okay, let me mark the option. So anybody else have found any different answer? Okay, so what I was saying is just Gm by R square will give the gravitational intensity on the surface of the planet. So I think now I can explain. So we have gravitational field on the surface of moon. Let me represent that using G subscript m, which is G. So capital G is just the gravitational constant, which is same for all the planets. So mass of the moon by radius of the moon square. Then similarly, gravitational field on the surface of earth is G m earth by R earth square. Now we just need to take a ratio Gm by Ge. The constant capital G will get cancelled. It's mass of the moon by mass of the earth, radius of earth by radius of moon, the whole square. Okay, so given that mass of earth is 80 times that of mass of moon, and radius of moon is fourth of radius of earth. So we okay, I use the capital R. We use that here also. So now if we just use these informations here, mass of the moon by mass of earth is 1 by 80, radius of earth by radius of moon is 4, square of that, so 4 square, so which will be 4 by 20 or 1 by 5. So gravity in the moon is 1 by 5th of gravity in earth, so it will be 5 times smaller than on the earth. So option C is the correct answer. Okay, so I hope that is clear. Any question? Okay, so if not, we will move to the next problem. So so we have two blocks on a smooth fixed wedge which are connected using a taut rope. The rope goes over a frictionless pulley as shown. If the blocks are in equilibrium, then the mass m of the second block and the tension in the rope are closest to. So basically we evaluate two quantities, the possible value of m and the tension in the rope T. So you can try this. I'll wait for a moment and then I will explain how to do it. So if anyone found the answer, so we have options given: combination of 3 kg 28 Newton, 4 kg 28 Newton, 3 kg 40 Newton, 2 kg 80 Newton, 2 kg 28 Newton. 5 options are there. Okay, so we have an option 3 kg 28 Newton. So we will see. Okay, one more. Yeah, again 3 kg 28 Newton. So I hope it is pretty straightforward. Everyone able to do it. So let me start explaining. So so we will go through the net forces acting on each of the bodies. So we have 5 kg block and then unknown m kg block. Okay, so 5 kg will have 5g weight acting vertically downwards, and m kg will have mg acting downward. So if we just consider the free body diagram of the 5 kg block, what are the forces acting on it? So one is this 5 kg, so 5g weight acting downward. Then from the surface there will be a reaction force acting, let's say it's R1. Then the tension T acting on the body. At equilibrium, these are the three forces acting on the body. Now this angle 35 degree, because this angle is 35. So now we can resolve the 5g weight into the direction of R1. I mean basically the let's say this is a horizontal and this is a vertical direction of the 5 kg mass. So we can just resolve the 5g weight into its components, which is 5g cos 35 and then 5g sin 35. So I hope that is clear. Basically we are resolving the weight 5g into its two components along the normal and along the tangential or tension direction. So then it will be easier to analyze. The same thing we can repeat here for the mass M, where mg is acting here. The reaction R2 will be acting here. They will be at an angle of 65 degree, which is this angle. Now the weight mg can be resolved along the direction of R2, which is 65, sorry, not 65, mg cos 65, and along the direction of tension, which is mg sin 65. So now we can consider the equilibrium of the block 5 kg. For that, its horizontal or basically the forces along the net forces acting on the 5 kg body should be 0. So if you consider along the direction of the tension, we have two forces, which is minus 5g sin 35, then plus t. They should be in equilibrium. So for that it needs to be 0. Now along the vertical direction, the R1, which is the reaction acting on the block, then the component 5g along the direction of R1, but in the opposite sense, which is minus 5g cos 35, they should be in equilibrium. So basically the second equation is not necessary here, but as part of the equilibrium equations I just wrote it, because that will only help us to evaluate the reaction forces. We want the unknown tension. The same tension will be acting on the other mass too, which will enable us to evaluate the unknown value of m. So from here we can see t is equal to just 5g sin 35. Okay, where g is 9.8 sin 35. So if we just evaluate it, so it's 5 times 9.8 times sine of 35, which is 28.1 Newton. Yeah. So yeah, I think our option is then correct. Okay, we have to also evaluate the mass m. So now we come to the second block, where if you similarly write the equilibrium equations, minus t plus mg sin 65, they are balanced, which is along the direction of tension, and now it's perpendicular direction, where we have R2 and then minus mg cos 65. They should be balanced. So this will enable us to evaluate the reaction R2, but that we really don't need. We just want what is the value of m. So from the first expression we can get m is equal to t by g sin 65. So t we know, which is 28.1 Newton by 9.8 times sin 65, which will give, let me evaluate. It's 3.16 kilogram. So the closest answer given in the option is 3 kilogram and 20 Newton, as earlier evaluated by you guys. So it was correct. So I hope this is clear. Anyone has any question? Okay, so we'll move to the next problem then. So a cable which supports a 50 kilogram load with the pulley arrangement as shown here. Neglect the friction and the weight of all the parts except the 50 kilogram, which is the only part which has a weight. Basically the weight of pulleys and rope, just neglect it. Find the magnitude of the total force on the bearing of the pulley C. Express your answer in Newton, round it to first decimal place. So we can try this. So basically we have to evaluate the net force acting in the pulley C. So there is no option. So if you found an answer, please type it in the chat box, then we will discuss. So for those who joined recently, so try to solve this problem by yourself. I hope can perfectly knowing what we have to find. So, okay, so basically it's asking to evaluate the net force acting on the pulley C. So if you see the pulley C, just draw the free body diagram of the pulley C. Only the C will have so C is actually hinged to a joint here, right? So you will have support reactions here, a vertical and a horizontal reaction. So it's asking to evaluate the net reaction force acting on this pulley. I hope it is clear. So for those who joined lately, so we can try solving this problem. I will wait for a while, then I will explain how to do this. So if you found the answer, you can put in the chat box. Okay, so I hope people are trying, and some people not have any idea of how to do this. So then let me explain anyway. So those who are trying, you can still try, and if you found the answer, put in the chat box. So I will try to explain it. So in this kind of problems you have a lot of parts here, right? So you can uh, start by having the free body diagram of each of the parts. Okay, so we have three pulleys A, B and C, and so we can have basically so the, also given that the pulleys don't have weight, only the extra weight 50 kilogram which is at the center of, which is acting on the pulley A, only that is a weight acting here. Extra thing that each pulley can have is that tension, which is the pulleys are like attached through strings, right? So the tension will be transmitted along the string. So that's another extra force acting here. So only these two forces are there, tension and this weight 50 kilogram. So we start from the free body diagram of the pulley A. So for that we have so basically the tension, yes, somebody has raised a hand. Any question? Hello? Okay, I think that's a mistake. See, you can unmute yourself and ask any question if you have, or you can just type in chat box. Okay, so so you can see here the tension in a string you can represent like this. If you want to split it into a free body version, like this. Similarly, you're trying to, it's like you're trying to cut the string. Okay, so we have T at A equal to 245 Newton. Yeah, we'll come to that. It's 245 Newton is the tension at A. So yes, we have TA here. Similarly, if you're trying to so let's call this as TB. Now TC is or TB is the same as T, that will come to. So this is how I split it. So if you now draw the free body diagram, so 50 kilograms, so that 50 times G is a weight acting on the center of pulley A, and two tension acting, TA acting here, TA acting here. So it's because it's the same string, you will have the same tension transmitted along the string. It's just the same string is binding here, right? So it's really the same tension. Now for the pulley B, this is the case. There is no weight acting, but yeah, TB is also given 122.5. Not given. Somebody has evaluated Newton. Okay. So we will see whether that is correct or not. So yeah, for see here in the pulley B we have TA acting here, and TB here and TB here. Now come to the third pulley C. We'll have tension T acting here, and then TB acting here. Also this is attached to support. So from a support you will have support reaction, a vertical force and a horizontal force. Let me call them RH and RV. So now we start from the first body or first pulley, which is A. So for equilibrium, so there is no horizontal forces, only vertical forces are there. TA, which are acting upward, and 50G is acting downward. So for equilibrium, the total upward force, which is 2 times Ta, should be equal to total downward force 50 times G. So I am not writing the formal sigma Fy equal to 0. I think it's pretty obvious that the upward forces should balance the downward force. So that Ta should be equal to 50 G by 2, which is 25 G. Now if you use the G to be 9.8, you will get indeed 245 Newton as the tension in A. Now use this information, come to the pulley B. Same thing, we repeat again. Here also TB 2 times acting upward, which is balanced by downward Ta. So 2 times TB should be equal to Ta. So the tension B should be equal to tension A by 2, which is 245 by 2, which is again 122.5 Newton. So these two parts we have done. Now come to the third one. C, where we have see, if you see here, the TB should be equal to T. It's not from the equilibrium thing, it's just that the same string should transmit the, it's not it is an inextensible string, so it should transmit the same tension across it. So the T will be just TB, which is we already evaluated, it is 122.5 Newton. Now we come to the we can now have the equilibrium for the pulley C. So if we see here, the tension T is given that it is acting at an angle 30 degree, so that we can resolve this into two components, which is T cos 30 along the horizontal direction and T sin 30 in the vertical direction. Now sigma horizontal forces equal to 0 for equilibrium in the pulley C. We will find that T cos 30 should be, it is in the positive x direction, minus RH in the negative x direction. So they should balance to 0, and sigma Fy equal to 0 gives that the vertical force, which is Rv upward, minus Tb, which is downward, and also T sin 30 is an upward force, so T sin 30, they should balance to give 0. So from the first expression we will get the horizontal force support reaction is T cos 30, and from the second expression we will find the vertical reaction to be Tb. Okay, so now we have answer in the comment, 157.4 Newton. So we'll check that. Okay, so I was talking Rv, the vertical support reaction from the second equilibrium equation, which is Tb minus T sin 30. So if we just evaluate, so remember T we already evaluated, which is 122.5 Newton, which is equal to Tb. So we can just evaluate RH is T cos 30. So it is 106.08 Newton, and Rv is Tb minus T sin 30, so which is 61.25 Newton. Now the resultant force, it's asked for the net force acting on the pulley, which is the support reaction, which is R equal to R horizontal square plus R vertical square root. So if we evaluate that, we will get 122.5 Newton, close to. So yeah, now I saw that in the new comment. So the earlier answer was wrong. So the resultant force now it's 122.5 Newton. Okay, so is that clear? Okay, so we'll move to the next question. If the net force on a particle of fixed mass remains constant with time, then which of the options are correct? So this is an MCQ type question, so only one answer is correct. There is no multiple answers being correct. So basically it says that the net force acting on a particle of fixed mass is constant. So basically it says that dF by dt is 0. I mean, it's not changing with the time, and fixed mass, so that means the dm by dt is also 0. These two statements, is that clear? Like from the whatever the statement given, I can just write these two expressions. So first one basically says the net force is constant, so with the time it is not changing, so its rate of change should be 0. The second says that fixed mass, so that mass is also constant, so its rate of change also 0. I think it's pretty obvious. If anyone has any issue here, please stop me, I will explain in detail. So if these two are given, then we can continue. So using Newton's laws of motion, we have F equal to mass times acceleration, or dp by dt. But for a I think we'll come through that. Okay, so acceleration also constant, as one of the answers in the chat box. That means option second, I think. So we'll come to that. So from Newton's laws of motion, we can write F is equal to dp by dt. Now P is mv, so that we can write is d by dt of mv. So it's m dv by dt plus v dm by dt, using the chain rule, not chain rule, it's product rule. Now dm by dt is 0 for a fixed mass system, so it will be just m dv by dt, or mass into acceleration. These all quantities are vector except mass, so I will just put that. Okay. Now given that df by dt is 0, so 0 equal to df by dt, which means that d by dt of mass times acceleration is 0. Again expand here, m da by dt plus dm by dt. I think we don't need to expand because mass is already a constant, so that expansion does not require. We can take the m outside because it's independent of time. This is 0, which means that da by dt is 0, which means that acceleration is a constant, which does not vary with the time. So as pointed out, second option is correct. So you can check the other options. The acceleration, the first option says that the acceleration of the particle increases constantly with time. That is not the case, because acceleration is a constant. It is not going to change with the time. The third option, the magnitude of the acceleration might increase or decrease at a constant rate depending on the direction of the force. now we have considered the uh, basically d by dt 0 means that the net acceleration in its vector form is constant, it's not varying with time. So acceleration is a constant, that's all. And the final one says that the acceleration of the particle is independent of the force acting on it. No, acceleration will be force by mass. It will be depend on the particle. So depend on the force acting on it from the Newton's law. So it is depend on. So that option is also wrong. So any question here? Okay, good. So we will move to the next problem. A cart containing sand is pushed with a constant force of 1 Newton. The cart and the sand together weigh 20 kg initially, and they are starting from rest. However, the cart has a hole at the bottom through which sand falls out at a rate of 45 gram per second. Calculate the velocity of the cart in meter per second after 1 minute. Round your answer to one decimal place. Hint is also given. Use Newton's law, F equal to dp by dt, to find the momentum p of the cart, and then consider p is a function of time, which is m of t times v of t, where m and v are the mass and velocity of the cart. So I hope the question is clear. So basically we have a system which consists of a cart and filled with the sand, and this entire system is pushed with a constant force, which is 1 Newton. Now during the process, because the cart has a hole, a leakage, through which the sand will leak through it 45 gram per second rate. So with the time, you can expect the mass of the entire system is getting reduced. As a result, the mass will be a function of time, its velocity will be also a function of time. You just need to evaluate what is its velocity after 1 minute. So so you can try this, and after a while I will explain. So if anyone found the answer, you can put it in the chat box. So anyone has any idea how to solve this? You can explain how, if you think you know how to solve it. So let me draw a schematic of what is happening here. So we have a cart which contains sand in it, which is pushed with a 1 Newton force here, starting from rest. Now after a while you see it is moved to some distance, maybe by using work done formula. Okay, so one of the comments says that we may have to use the work done formula. I don't think we need to use work done formula. Hint is given that we just need to use Newton's law. f equal to dp by dt, and remember that p is mv. So you cannot always write f is equal to ma, which is not Newton's law, which is possible only if the mass is constant. There are a lot of situations. Usually in rigid body dynamics you will see the mass of the body is conserved, it is constant, but in several cases, for example rocket propulsion, the mass of the body is not conserved, it will change. So as a rocket get propelled, it is ejecting, after combustion it is ejecting the a part of mass. Yeah, so as comment, as in the comment, dp by dt is the correct law always. So this is the correct expression, and d by dt is m times v. So whenever mass is constant, you can take it outside and write m into dv by dt or ma. But remember, when mass is not a constant, you will still have one more term, which is dm by dt times v. So dm by dt I can write as m dot, which is the rate of mass change. So for example, for rocket the mass is changing continuously, so you have to consider. So here it is a similar situation. So the mass of the body is changing. So let's assume that if there is no leakage. Okay, before that let me finish the diagram. So the mass is now, the amount of sand is now reduced because there was a hole to begin with, through which the mass was leaking at a rate m dot. So the dot represents the time derivative. So let the system initially has a mass of capital M, or m0, capital M0, which is consisting of both the cart and the sand. Together it is 20 kilogram. Later we find that its mass will be decreased. So let's say from here to here it took t second time, from here to here for the motion. Then mass at this time will be initial mass minus the rate of leakage of mass is, let's say, m dot, which is given 45 gram per second, times t. So this much mass will be leaked out of it, and you will only have the remaining mass for this particular system. So this is now basically a linear function of time. The mass will be a linear function of time. So I hope this is clear. At any time you can see the mass of the system will be m0 minus m dot times t. So this is the actual scenario we are looking at. But let's say let's assume there is no mass leakage. Then m0, after t time also the system still have m0, and you are given that the body is acted by F equal to 1 Newton. After time t, what is its velocity? If there is no mass leakage, how will you evaluate this kind of question? So why I do this is that there was a doubt that we may have to use the work done formula. We really don't need, we can just use F equal to dp by dt to solve the problem. So for this special case that now we are considering, it is d by dt of m times v. Since I told that now the system, assume that the system don't have a mass change, m will be constant, which is m0. m0 we can take outside, times dv by dt. Okay, now f is given, m0 is given, so we will get acceleration. We can dv by dt is acceleration, we can integrate to obtain the velocity, or rewrite this entire expression as dv by dt as f by m0. From this, v will be the integral of f by m0 over time from 0 to t. So when we do the integration, remember on the left hand side also we need to do the integral. So it will be v of t minus v of 0, the velocity at the time t minus velocity at the initial time 0, because we are integrating from time 0 to t, just the integration limit. Just that it's given, initially it is starting from rest, so the v0 will be 0. So in that case the v velocity of the body at time t will be just 0 to t f dt by m0. In the current situation, f is 1 Newton, which is a constant force, so 1 by m0, which is 20 kilogram. So I told you to assume it to be a constant, so it is just 20 times t, times integral. So they are constant, we are taken out of the integral, then we are just integrating dt, which is just going to give t. So at any time the velocity will be t by 20. This is the solution if we assume the mass is not leaking and remains constant. So is that clear? If so, now we come back to the actual situation. So this is just an assumption that we have, thinking that there is no mass leakage, which is not the case. There is mass leakage, so that the system mass is changing with time. Basically m is not a constant, m is a function of time. Just we need to remember that. So we will repeat the same process now. So f is dp by dt, which is d by dt of m times v. Now both m and v are functions of time, so we cannot just randomly take m outside the derivative, because m is m0 minus m dot times t, where m0 is 20 kilogram and m dot is 45 gram per second. To make everything in the same unit, it's 45 into 10 raised to minus 3 kilogram per second. Okay. So from this we can integrate this expression directly as f dt integral 0 to t. We will evaluate m of t times v of t minus m0 times v0. Now from this we rearrange it, we will get m0 v0 plus f dt integral 0 to t, the whole divided by m, which is m of t, which is we know, which is m0 minus m dot times t. This is equal to v at any time. Any question in this part? So I hope this is clear. Then we just continue. So now v of t is m0, which is 20 times v0, which is initially in rest, right? So starting from rest, v0 is 0, plus f dt integral. Now f is a constant 1 Newton force, which is a constant I can take outside, 1 times integral of dt from 0 to t, which is just t, that time, which is given that 1 minute, so 60 seconds, the whole divided by m0 minus m dot times t, which is the m at the time t. So here m0 is 20 minus m dot, which is 45 gram per second, because we are converting to kilogram, which is 45 into 10 raised to minus 3. Then time is again, like I said, it's 1 minute, that is 60 seconds. So you can evaluate this expression. So I think it comes around 3.4647 meter per second. So this is the velocity of the system after 1 minute. So any doubt? Okay, good. So I think this is clear. So with that, I think I can stop today's session. um, so if you guys have any questions, you can ask. I'll try to answer them, or if not, we will stop for today, and we'll meet next week again. So any question, any doubt, like from today's session or generally in the week 1, week 2? Okay, so I hope nobody has any questions. So then we will end for today. Thank you.